All right, here we go. All right, listen. Do not freak out. I'm about to give you an example, and I'm going to run through a proof of how the rule came about. If you have no clue of what I'm doing, then really all you have to do is memorize the rule, which probably is going to happen. That's all you're going to end up memorizing is the rule. But this is really for my higher level math people that have to go on to higher level math. Okay. So you are going to find the derivative of y equals 2 to the x power. Okay, this is what's called a general exponential. This is a base raised to an exponent power. There is a rule for it. And instead of me, like I did yesterday, just give you the rule, I actually want to show you how it's proved. So, again, bear with me if you're like, I didn't know that I could do that. That's fine. Just memorize the rule part. You're going to be good. All right. So here's basically how the proof part comes about. What they do first is they rewrite it as y equals e to the ln of 2 to the x. Why are they allowed to do that? What do we know about e to an ln? It cancels. Okay, right, Jack and Eli? I can see. The second reason they did this is because we know a rule for e powers. The rule for e to the anything is what? What's the derivative of that?
1 over that times the change.
It's that times the change, right? It was that time. Yeah, exactly. So it's like, so what they just did was, all they did was add a 1 in there, and they just rewrote it, and it didn't do anything to the problem. It didn't mess up the problem, kept it equal. But they did this to take a derivative now. So if I take a derivative of this, okay, this whole thing right here becomes my u, okay? So if you want to write it on the side, u would be ln of 2 to the x, okay? I should rewrite this over here. Well, we just did this yesterday. What's the derivative of ln of anything? We just did that yesterday. 1 over that, okay? But even before we do that, let me show you something else. What can you do with this x? Oh, so I can actually rewrite this as x ln 2.
That's x 1 over 2.
Okay, no, this is where it's going to kind of blow your mind, and this is where the other class was like, what? Okay. The ln of 2, if you were to go to your calculator right now, couldn't you punch in ln of 2?
Right.
And it's a what? Number, okay? So just like, look up here at the board, I did this on purpose. Just like if I said, what's the derivative of 5x? You would say what? 5. What's the derivative of pi x? You would say? What's the derivative of ex? What's the derivative of ln 2, which is there really a coefficient x? Oh.
ln degenerate.
So many of you want to write 1 over whatever. Don't. This is actually a coefficient, and the derivative of a coefficient in front of x, I mean, even though I don't have it in front of x, it's to the side. The derivative of that would be ln 2. Okay, but we haven't finished the problem. So again, the derivative of e to the u is e to the u times the chain, right? It's always e to the u times change. So if I substitute this u in and I substitute this u prime in, I would get e to the ln of 2 to the x times ln 2. Do you agree? All I did was just substitute it back in. And then the third step is, so they took a derivative. This third step is they actually just rewrite it again, and they cancel out that e and ln. And you get 2 to the x times ln 2. Now, how could you go from here, which was our original problem, to here? What general rule could you give me for anything that looks like this? And so what do? You write it again? Didn't I write it again? And then I multiplied it by ln of the base. That's all you do every time. So the rule for taking a derivative of, and I'm going to write it as a base to a u power, okay? Why to a u power? Because we might end up having like 2 to the, cosine x.
How can you just put something to the e to the ln?
Because e and ln cancel. I'm allowed to do that.
Can you only do it to the other side, like with the y too?
No, because that's just it's just something that I can cancel. That's fine to do. You can put anything that will cancel
You put
itself.
+0 anywhere you want.
Yeah, and it doesn't do anything to the problem. Equals. So what would be my derivative of this? What would you write? You would write it again times the natural log of a, but then we always want to attach the chain, which would be u prime. Okay? So there is your general Earl. How do you feel? That was a proof. It's called an algebraic proof, but it's a proof. It's what happens for a general form. If you didn't like that, listen, just know this rule then. That's the rule that we're going to work with today. Okay? All right, now, the second rule that we're learning today. Shoot, there's 2 today. Okay? Find the derivative of y equals log base 2 of x. So yesterday we did natural log, but today we're doing log of a different base. So log base 2 or log base 6 or log base whatever of x, okay? So again, I'm going to show you the way the proof is constructed algebraically using this example, okay? So what they do is they actually rewrite using change of base formula, which is what we learned yesterday, or we refreshed. So you can rewrite log base 2 of x as how? What's the change of base formula say I can write it as? Log base x, log base 10 of x over log of 2. Or, even better, let's do it into ln's because I know a derivative of ln. Remember I showed you yesterday that log of x over log of 2 is the same as ln x over ln 2. It's the same thing. Okay?
Okay.
All I did was rewrite it with the change in base formula. Now, here's what you're going to have to get inside your head if you haven't gotten it already. ln2 is a number, right? It's like 5. It's like pi. Okay, ln2x, that's a totally different thing you're going to have to do a derivative on and whatever. But ln2 is just a number. So I could even rewrite this, watch, even a better way for me to rewrite this, let me move this over, would be 1 over ln2. That's like the coefficient pulled out to the side, and then ln x. And now I'm going to take a derivative of that. So again, the derivative, this is just a number. This is like 3. I know it's not 3, but I'm just saying it's like 5. It's a number in front. You did this yesterday. If I had 5 ln x, whoops, do you know how to take the derivative of 5 ln x? What would it be?
5 over x.
5 over x, right? 5 times 1 over x. So if I have a 1 over ln2, it would just be 1 over ln2, which is like your 5, times what's the derivative of ln x? 1 over x. Or even better, a better way to write it, what would be, I like to put the x in front, would be x ln2. Okay, now, once again, let's try to go a rule from here to here. Can you give me a rule from here to here? What would be a general rule that you'd write? Rule for the derivative of, let's call it log base a of a u. Okay, I know it's a lot of letters, and you're like, I'm confused, but yeah, okay, here's my log, here's my a, here's my u, here's what I ended up with. So 1 over what? U times ln of a, and then don't forget the chain, which some books have it on top. Okay? Okay. Are you ready? You got this. Now, all of my examples today are way harder than the actual worksheet. And I do this on purpose because I'd rather give you the hard. I feel like if you can do the hard, you can definitely do the easy and bang through it. And my method is true because I saw all the students in last class. They were like, bang, bang, bang. They killed it. They complained, but they killed it. All right, so here's my example one. Hey. Y equals log base 7 of 6x to the 4th plus 3 to the 5th power. Okay, so you're not going to rewrite it. We already know the formula and everything like that. So we're going to use this formula here. Let me bend my paper. There we go. I mean, you have it in yours. We're going to use this one right here. Okay. But what do you think you do with that 5? I mean, should I multiply this all out 5 times? No, bring it to the front. Y'all, if you got logs and you got exponents, I mean, bring them all to the front. So let's rewrite it as 5 log base 7 of 6x to the 4th plus 3, okay? All right, so now, again, looking at this rule, log base A of u equals 1 over the u times ln A times the chain. Okay, so what again is my u? That. What is my A? The base. Okay, and then chain, we're going to multiply it. So what do I do with the 5? Just keep it there. He's a coefficient, so he gets attached. So 5. Now what would I write?
1 over 6x.
1 over, hold on, Jack's already knowing, this is my u, 6x to the 4th plus 3 times ln A, so ln of what? 7 times the derivative of the u, what would that be? 24x cubed.
Why is the ln on the bottom?
That's where we put it, remember, we just proved it.
Okay.
Okay.
You don't really need to know why you do.
No. So now these are, yes, honey, these are all fractions. So if you know your fraction multiplication, you multiply the tops together. 5 times 1 times 24x cubed, 5 times 24, I think, remember. 120, is that 120?
Yeah.
I hope it is. 120, x cubed would be on top. The bottom would be 6x to the 4th plus 3 ln 7. Can I clean this up? Am I allowed to cancel anything here? No. This is a binomial. This is a monomial. No, not unless you got monomials. ln 7. You're done. That's it. How'd you feel?
Do you still want that like binomial in the front?
I would, because I feel like if you put it in the back, you would distribute a 7. Some people are confused there, so that's why I don't do that. All right? Second example. And again, we're finding the derivative, so this one's fun too. I know. These are hard, let me tell you, and I'm kind of doing this specifically for my college people, but I think you all can handle it. I think you're smart enough, and I like you all. All right. What is this? This is,
You gotta.
no, don't get confused with what you did yesterday.
What's your roll?
Yeah, listen, a lot of people did that yesterday too, and I don't know why, maybe because we were doing so much in our homework. Are you allowed to separate this with minuses? No, there's not the word ln in front. Okay, so you can't do that. But this is a quotient, is it not? So you have to do quotient rule. Okay? So quotient rule says denominator. Okay, so 3 to the x plus 2, there's your denominator, times the derivative of the numerator. Okay, so let's go to this rule now. Let me pull it up here. Okay. Let me bring it up here so you can all see it. So this is an a to a u. The derivative of that would be, write it again, a to the u, times the ln of a. So what would I say? Write it again. 3 to the x times the ln of a. What would the ln of a be? what do I write? ln of 3 times the chain. Well, the chain of x is 1, so I don't have to attach it if I have to. Okay? So first times derivative of the, I'm sorry, not first. Denominator times derivative of the numerator minus numerator times the derivative of the denominator. Wouldn't the derivative of this be that again?
Yeah.
And what's the derivative of 2?
0.
So I'm just writing that again. Denominator times derivative of the numerator minus numerator times derivative of the denominator, all over what? Okay. Now, oh,
Again, because the derivative of 2 is 0.
huh?
You say that it's like, it's the same because 2 doesn't.
Yeah, because it's plus 2 and its derivative is 0. Okay, so now, I know, this is fun. We got to distribute.
So
Why don't we just factor it out?
We could factor it out. You want to do that?
Yeah.
Then you just like cancel out the 3.
Yeah, oh, that's what we're going to do. I just want to distribute. Do you mind if I do? But yeah, we could factor. Oh, I'm going to distribute. Let me stick with my guns and then I'll do it here. All right, here's why. I'm just trying to go back over exponent rules. When you multiply like bases, do you change this to a 9?
No.
No. You keep the base, and what do you do with the exponents? Add them. So what would it be? 3 to the what?
3 and 2.
2x ln 3. When you multiply something that has an exponent times a 2, am I allowed to say, oh, that's 6?
No.
No. I actually could only write it as 2 times 3 to the x ln 3. Okay? So I did this times that, minus, what does this become? What does 3 to the x times 3 to the x ln 3 make? Isn't it the same thing that we just did? Oh, well, and that's great. So what's going to happen there? Oh. Over 3 to the x plus 2 squared. And that is actually the answer. That is that is definitely a harder problem. You won't be seeing as hard, but I thought that was pretty good and challenging. All right, one more, and I'm done. And this is really, really for my higher level college peeps. But,
Wait, do we have to do it then?
yes. Last one.
Are we doing anything else?
No.
I'm just trying to explain.
And this actually, I probably should have done this as my first example because this really deals nothing with what we just did. It's just a harder problem and I like it. It's fun. And my people who are in the,
Cut the whole cross.
Is that an
one's doing it.
What?
No.
I was right now.
Oh.
Star this. Okay. All right, so the directions for this one are actually quite different, and I probably should write the directions. They're actually going to say use log forms to take the derivative, or something like that. I'll look it up for you in a minute. But anyway, you are going to rewrite with ln on each side. Again, why am I allowed to do this mathematically? Whatever you do to one side, you can do to another side. Okay? If you want to add 2 to one side, you can add 2 to the other side. If you want to square root one side, you can square root the other side. You want to ln one side, you can ln the other side. Okay? Jed asked a question before, why didn't I do that with the e to the ln? Why was I allowed to do that? Because you were adding like essentially an identity, like 0. So you don't have to add 0 to the other side. It's unnecessary. Okay? All right, so let's keep this like this. Let's keep this side as ln y. But what should we do here that you did all last night for homework when you're dividing inside an ln? Separate it out. Good job. So ln of x times square root of 2x plus 1, what would be the sign here? Minus ln of x squared e to the x. Let's go even further. Now we're multiplying inside of an ln. Now what do I do?
You add that.
Now I can separate by adding it. Very good. ln y equals ln x plus. How do I write that one?
1/2.
Ooh. Of 2x plus 1. How do I write this one?
2ln.
Nice. Minus 2 ln x. By the way, let's put this in parentheses because we are going to have to distribute that minus. And then plus what? ln of e to the x. Don't we know something about this?
You cross it out.
Oh, and the x comes down. Do you see the beauty of this, y'all? No, you're like, no.
There's no beauty in this.
It's a beauty. I love it so much. I can't help it. All right, I'm just rewriting it because I want to distribute my negative. So minus 2 ln x minus the x. Okay, so all I've done here is just properties of logs. That's all I've done. I've expanded. I've expanded, if you want to write expand. Okay, and now I'm going to take a derivative of both sides. And whenever I take derivatives that have y's, then I'm doing it implicitly, which means I'm doing the whole dy dx lovely thing, okay? So let's take a derivative now. So let's do it implicit differentiation right here. What would be the derivative of ln y? Good job, you're so stinking smart. Okay, what's the derivative of ln x? What's the derivative of 1/2 ln 2x plus 1? 1/2 stays there times the derivative of this, which is times the chain of that. So what happens there? They cancel, just comes 1. Okay? What's the derivative of 2 ln x?
It's 2 keep the thing.
2 keep the thing times 1 over x, or 2 over x, wouldn't you agree? Okay? And then what's the derivative of x? Minus 1. Yeah, if it was a constant. All right, so now let me just clean this up just a little bit for us, which you should all know how to do. You can actually combine, these are like terms. What's a 1 over x minus a 2 over x? So I've got 1 over 2x plus 1. I've got minus 1 over x, and I've got a minus 1. Do you all agree on that side? All right, and then what do I do with Mr. 1 over y here? Multiply this whole side by y. What? I'm going to let you leave it like this, but people might want it as one fraction. But here's the thing that I've never done with you before. You would just distribute the y and you leave it at this point, but really, don't we know what y is equal to?
Wait a second.
So your final answer is actually, wait for it, 1 over 2x plus 1 minus 1 over x minus 1. If you want to write it as one fraction, you'd be even better, times x square root of 2x plus 1 over x squared e to the x. And that way, if they ever give you just an that way, if they ever gave you just an x, you know how sometimes we just get just the x? We have to figure out the y to plug it in. You could do the problem with just the x then, is what I'm trying to let you know. What? Look at this goodness. All right, now, that was hard. Welcome to your chapter test.
Wait, do we have to do the?
This is really
Allison's like, what? Go ahead, sign up for it. No, you'll be fine. You'll be fine.
Do we have to distribute that?
No.
Who comes up with these problems? I want to know.
All right. So just real quick on this sheet, real quick. Yes, you do have to do all of them. You have the rest of the time to do this, okay? But I'm going to be kind to you. I'm going to I would write at the top right now all these wonderful derivatives that we have learned in just this one section. For example, okay, actually in two sections. The derivative, you could put d dx, whatever, of e to the x, okay? And by the way, all of these I could put a u right here, but I'm not. What happened? Oh, neither of you got one?
He got one, I just didn't.
I'm sorry, honey. I thought I put two. All right. The derivative of e to the x is what? What is e to the x? If it was like x squared, then you multiply by the chain, correct? Okay. I'm just trying to do some quick ones. Then we learned the derivative of ln of x. We learned this yesterday is what?
Ln x.
1 over x times, again, its chain, which would ever be that. I know. Wait, we're not even done. We haven't done trig derivatives yet, y'all. So just wait. Then today we learned about the derivative of a base a to an x. So it's kind of like e to the x. You write it again, a to the x, and then you put what? ln of a. So this would be like 3 to the x, 8 to the x, 7 to the x, some base number here.
That is hard.
Okay, just like e to the x, write it again, attach ln a. And then last but not least,
What about the chain?
well, again, if it had a u here, but all of these aren't going to have u's. Your test might though, but just that you attach the chain. Your test might have it. Just attach the chain. Okay, and then what was the last one we did? Log, right? Yeah. Log base a of x. Okay. So what was that one? Again, you have it.
It's 1 over.
1 over the, I think I said u, so x, ln of a. And then again, if it has something else, it'd be a chain. All right. You're going to do all these. These are easy. 1, you know how to do. 2, you know how to do. 3, you can do. You can do these very quickly in the beginning. Okay. Get this done. Work together. I've blown your minds. It makes me so happy.
Oh.
Midpoint formula?